Okay, so let's draw a picture of what's going on here. So the street light is 17 feet up. 17 feet. So here's the light. Okay? And then the approaching is, here comes the man. And he is 5.5 feet tall. Okay, at what rate is the end of the man's shadow? Okay, so then the light is going to shine down and create a shadow on the ground, right? So this is shadow right there. When he is 7 feet from the base of the light. And this is 7 feet. Okay, so here's kind of the setup of it. And we know, and also says that he's approaching at 4 feet per second. But I think that's all the information we have. This, the height is 17, his height's 5.5, he's 7 feet from the light pole, and he's moving 4 feet per second towards the light pole. So what was the first thing we wanted to do? What's that? Should find an equation that relates the rates. Is that the first thing we want to do? No, that's like kind of the last thing. I mean, that's like the goal, right? So, but that's good. So we're going to find an equation that relates the rates. So the first thing we want to do is determine, just ask the question, what are these rates that we are going to end up relating in the end? So can you describe what rates are involved here? The rate at which the man is moving towards the light. Okay, so if we want to express that in terms of quantities, how could we express that in terms of quantities? So Tyler said the rate that he's moving towards the light, which we know is 4 feet per second. So how can we symbolically show that?
You assign a variable.
What? So and what it? Assign what a variable?
The distance between the light post and the man.
Okay, so you want to say from here to here, which is currently 7 feet, but that's changing, right?
Mm-hmm.
What do you want to call it, Adonijah?
X.
X, okay, so he wants to call it X. So is that the rate? Is the rate X 4 feet per second? Is that X?
No.
No.
dx dt is 4 feet per second.
And it's dx dt to be 4 feet per second. Agree? So anyway, dx dt, we got that. What else? Shadow length. Okay. Well, we don't want to call it X. We already got X. So what do you want to call the shadow length? S. Okay. That's good. And it says at what rate is the end of the man's shadow moving when he is 7 feet from the light? So what rate is that? ds dt? So imagine how fast S is changing. How fast S is changing. Is that how fast this is moving?
No.
Sharon, why not?
Because
So say it again now.
That the rate that the man is approaching the lamp isn't the same as how fast the shadow is moving.
My question was, is dsdt, how fast the shadow length changes, is that the same as how fast that point is moving? Because the question is asking how fast that point is moving. Is how fast that point's moving the same as how fast the shadow length is changing? Yeah?
You have to add to it the speed of the person walking.
How come?
Because so it's the shadow is attached to the person. So
Okay.
the shadow is moving, and then it's also changing.
Okay. So what is the answer? What rate is the answer to this question? Meaning, at what rate is the end of the man's shadow moving? So that point right there.
dx dt plus ds dt.
He wants to add these two together. If we add these two together, will we get how fast that point is moving?
Yeah.
Because it would be how fast the man's moving plus how fast the shadow length is changing. Together would result in how fast that point moves. Some people are nodding. So that's an important realization when you're solving this problem. Okay, so yeah, we can relate dx dt and ds dt, but we got to note that the answer to the question is neither of those. Because how fast that point is moving is both has a contribution of how fast the shadow length is changing, but also with how fast the man is moving. So maybe instead, what could we do? We could define this quantity. Maybe let's call that x. And then, what about dx dt?
That's the value you're looking for.
That would be the answer we'd be looking for, right? So let's, instead of calling this x,
X minus x.
yeah, if we need that, this would be then x minus s, if we need it. But let's call it all the way from the tip of the shadow to the light pole x, and then the length of the shadow s, and then the answer to our question will be dx dt. Is it okay? All right, so what do we need now? So we find an equation that relates the rates. What was next? What's that? Okay, Lauren, great. So we want to relate these rates. In order to get the related rate equation, it's going to come from an equation of the quantities. So what quantity is associated with dx dt? X. What quantity is associated with ds dt? S. Okay, and then we want a relationship of those quantities. If we can get a relationship with those quantities, then we can get a relationship with the rates. Okay, so my hope is that as you were working these, this was your thinking about each one of these, instead of just trying to kind of figure them out, right? So that's what we practice on Friday. First, identify the rates. Step 1. Step 2, identify the quantities associated with those rates. Step 3, get an equation of those quantities. All right, so how can we relate these quantities, x and s? How are x and s related?
Yeah, you have two similar triangles.
Yeah, so some people are saying similar triangles, right? You got this triangle right here, has all the same, is the exact same shape as the big triangle. So we have proportionality of sides. Okay, so we could say that s over 5.5 equals what?
X over 17.
X over 17. Okay? Or in other words, 1 over 5.5s equals 1 over 17x. Last step. So we're going to implicitly differentiate with respect to what variable?
Time.
With respect to time. Okay, so what is the rate of change with respect to time?
1.5 Or 1 over 5.5 dx dt.
Yeah, 1 over 5.5. That'd be the derivative of that. But then, by the chain rule, ds dt. Same thing, 1 over 17 is the rate of change of that, but by the chain rule, dx dt. Okay, so what is this thing right here? What's that, Beth? Yeah. What are these problems? Related rates, right? That's what it is. That was our whole goal from the beginning, was to get an equation that relates the rates. So first we identified the rates, then we identify the quantities associated with the rates. We get an equation of those quantities so that we can get the equation that relates the rates. All right. And the one that we're trying to solve for is?
dx dt.
Right, we said dx dt, how fast that whole length is changing relative to the fixed light pole would be then how fast that thing's changing. All right, so there's our unknown. So if that's our unknown, then with the information in the problem, we should know everything else. So easy, 1/17. So the only thing we have to do is ds dt. How are we going to get ds dt? No,
We don't know dx.
we don't know dx dt.
We know dx minus s.
Okay, so what now? So we've got the thing we haven't used yet is that the man is walking 4 feet per second, right? And according to what we've set up, that is what? How this thing changes with respect to time. Equals?
4.
Does it equal 4?
At oh, yeah, it was 7 feet. dx minus s dt at 7 feet equals 4 feet.
So this quantity x minus s, what's happening to that quantity? Changing. How's it changing? Decreasing, right? So if that quantity, that's like an accumulation, right? It's an accumulation that's decreasing. Accumulation is decreasing. What about the rate?
So it's
Negative. So yes, he's moving towards the flagpole at 4 feet per second. But if you call that the rate of change of that distance, you have to call that -4 because that distance is decreasing. So then how do we, this is how we're going to be able to get ds dt. How do we take the derivative of a difference? So we're taking the derivative of x minus s. It's easy, right? We've been doing it all semester. It's just the difference of the derivatives. So ds dt then is dx dt. So I'm moving this there, so it's going to be +4, is that right?
Yes.
So now I can take that and put it in there, and then I could solve for dx dt.
Or did the 7 not come into play then, ever?
The 7.
7 feet from the base of the line.
Yeah, so basically what this is saying is that the rate of change doesn't matter how far you are away. How fast that point is moving is not dependent on the fact that he's 7. This equation tells us that how fast that's moving is not dependent on how far he is away from the light pole. because it's not how far he is away from the light pole isn't part of that equation. You see?
Gotcha.
Okay. Other questions? Lots of people just tuned out. But okay.
Once you put that over there, though, don't you have to get all the dx dt on the same side?
Yeah, it's just solving from here on out.
I know, but if you subtract the ds dt from a positive dx dt, then it becomes 0. No?
You got 1 over 5.5 times this whole thing equals 1 over 17 times that. Dx dt isn't going to be 0. It will? Yeah, but it's this on this side it's multiplied by 1/17. On this side it's multiplied by 1 over 5.5.
Okay, so you divide it by.
So it's not going to cancel out. You got 1 over 5.5 times dx dt and 1/17 times dx dt. What's that? So that should be pretty easy to solve. And you should get should this be positive or negative? Should be negative because that quantity x is decreasing as well, so its rate of change should be negative. Okay. Other questions? Okay, can I erase? Okay, so related rates will certainly be part of your quiz on Friday. If you want to discuss more of these problems, we can't spend any more class time, but if you want to go over more of these, please come to office hours with Owen or myself, and we're happy to go over as many of them as you want. Okay, so we want to talk about, the next thing we want to talk about is, and we've been doing a lot of this all semester, but we want to kind of formalize it, and that's what can you infer about the original function by having information about the rate of change, okay? So inferring information about a function from given this rate of change. Okay, so here's some notation right here. Rx equals df dx. So what is this talking about right here?
Rate of change function is equal.
Someone besides Adonijah. Love your enthusiasm, but we've got to balance it out here. How about Talia? Tell me something about this equation right here.
The R of x equals the rate of change of f of x with respect to x.
Okay, she said this function r of x is a rate of change function. And it's the rate of change of f with respect to x. Dan, you agree with that? Yeah, exactly right. Okay, so what kind of function then would we think of as f? Or maybe might we think of as f? What just in general, what kind of function? What's that? How are you getting that? Linear. Could it be an accumulation function? Could we have a rate of change from an accumulation function? Yeah, right. We're doing it all semester, right? That's what we're doing. Okay. So you're supposed to be like after the weekend. You're supposed to recreate. You're supposed to be like ready to go, right? Not tired, but we get tired out from our recreating, right? That's what Americans do. Okay. All right. Here we go. So could this be? How about a rate of change function? Could f be a rate of change function? Could a rate of change function have a rate of change function have a rate of change function? Sure. Right. Okay. So this really could be either. It could be an accumulation function for which we want the rate of change, or this could be a rate of change function for which we want the rate of change. Okay. So it doesn't matter. But what we do know is that R is the rate of change of f, whatever f is. Okay. How about this? Now we're saying, so n is our x value. Right now, this is showing that we're at -5. So x is -5, and it says R of -5 is 59. Okay, what does that mean? R of -5 is 59. Jacob, can you tell me one thing about that?
It's going to be positive.
What's it? So it is a 4-letter word today. There's going to be lots of things we're talking about. What's that?
Rate.
The rate is positive. Certainly the rate is positive because it's 59. Anything else? We can listen one more.
It's going to be large.
What's that?
It's going to be steep.
What's it? What's gonna?
The
What's
rate is going to be a steep increase.
the rate? Is a steep increase. Marcus.
The rate of change at -5 is equal to 59.
Okay, the rate of change at -5 is equal to 59. Okay, what does that mean? What does it mean that the rate of change at -5 is 59?
Is it of the function f?
Well,
Oh no, because -5 are those related? Those two.
this is a graphing calculator file. So this is the first, in this line, we've defined that R of x is the rate of change of f. So now here I'm asking graphing calculator to tell me what R of n is. Right now n is -5. Does that answer your question?
So n and x.
Yeah, n is the x value.
Okay.
And so by putting it here, it's the input into R. By putting n here, we're saying whatever n is, make that the input into R. So that is acting as the x. Yeah. Okay, so what does it mean that the rate of change at x equals -5 is 59? Have we learned anything this semester? Yeah, Daniel.
So, changes of y of f of x are 59 times bigger than changes of x of f of x.
Okay, so you said changes in y are 59 times bigger than?
The change in at -5.
Okay. So is this equal? About? Approximately equal. And you said at? Okay, what about if delta x was 1? What do you think about that? What's your reaction to that? If I said delta x is 1?
The rate of change is 1. Have a different. It's changing.
What's that?
The rate of change is changing, so at 1 it would be different.
At 1. Here?
Oh no, that's delta. The change.
Delta x, the change, okay. So what did you mean by that? You didn't mean at 1.
So when the
So here at -5, delta x equals 1. It'd be a -4. So what about this, talking about what's your reaction to changes in y are 59 times changes in x, and I'm going to say delta x equals 1. Beth? Shaking your head. Jacob?
The change in y will be approximately 59.
Change in y would be approximately 59. Yeah, Talia.
So it's over a much larger interval,
Okay.
so it's gonna vary a lot more than 59, I guess.
so that's too big of a step.
Okay, good, right, exactly. So by the time we get to -4, what about the rate of change? Is it still 59?
No.
Could be much different. So this is, what qualification do we have to put on this statement here?
True, yeah, for small.
Yeah, so delta x would, for very small changes delta x. Because as soon as we make delta x even a half or 1, it's too big and the rate of change could change itself. And this won't hold. Okay, so
So for small,
for a small change in x, what's y going to do relative to that change in x? Okay, based on that statement right there, can we make any conclusion about the function f? So this is the kind of thing we want to ask now. Knowing something about the rate, can we make a conclusion about the original function? Andrew, can I say anything about f if I know this is true for small changes in x close to -5? Adelaide, what do you think?
Are you asking like what the function looks like in this graph?
Well, I've only given you one number, so I'm not asking you what the function looks like, but something. Can you make any conclusion about the function? Yeah.
Well, possibly that it's linear because I'm moving up the linear.
Okay, it's linear.
you could say that at that function, at negative 5, and small changes has a range of 59. You can only say that for that particular point.
But what can you say something about the function f?
With respect to that point.
Uh-huh. Stanley?
Increasing.
Is f increasing? Can you conclude that f is increasing? Yeah. Because why? Because suppose we start here and we make a little change in x. What will happen to y? It'll be way up here, right? 59 times, whatever that change in x is. So, therefore, the function must be increasing. So that's the kind of thing we want to talk about. So now what I'm going to do is I'm going to let x change from -5 to -3. And I want you to watch what the rate does. Okay? So I'm going to change x from -5 to -3. Keep track of what the rate does. Ready? Here we go. Did you see it? All right, let's do it again. Ready? Here it goes. Watch the rate. So let's kind of mark down what we know. So between -5 and -3, so can you make any conclusions about f? And what do you know about r? So let's kind of write down what we know about f and what we know about r. Do it one more time. Okay, so the goal of this is not to come up with phrases like increasing at a decreasing rate and decreasing at a decreasing rate and okay, that's not the goal, because those are kind of confusing. We want to split it apart and talk about what the function is doing and what the rate is doing. Okay. So ready, one more time, from -5 to -3. Okay, so tell me about the rate. What did the rate do? David? Judith, what did the rate do?
The rate decreased.
Decreased.
A lot.
From, okay, a lot. Is that the only thing it did? Decreased?
It stayed positive.
and stayed positive. Is that true? Did it always decrease through that interval? Just making sure. Did it always decrease?
Go back.
Here we go. Ready?
Yes.
Okay. Decrease the whole way.
It jumped like it was smaller, then it got bigger.
If it got smaller, then got bigger, then it didn't decrease the whole way.
No, I mean,
Did it decrease the whole way?
it decreased the whole way. But it went from like 28 to 20%.
So, is this a correct result? R is decreasing the whole way through. Is that right? Cool. Okay. What can we say about F?
Continually increasing.
He says continually increasing. The whole way. Okay. What about what can we say if F is positive or negative? Tyler, why not?
Because you don't have any values, you don't know if it's increasing, but it started at netting 100.
Okay.
So you don't know where that graph is.
I didn't give you a starting point for the actual function value of F, but we do know that it is increasing over that interval. Okay, but R was decreasing. Okay, let's go from -3 to -1. Ready? Here we go. Watch. All right, I'll do it again. Ready? Watch. Here we go. Okay, tell the person next to you, what did you see there? What did you see? F and R. F and R, and I'll do it again in a second. Tell the person next to you. Here we go, I'm going to do it again, ready? One more time. Here we go, one more time. Okay. So what happened to R there? Richard? Continue to decrease. So R is decreasing. Can we be more specific? Became less positive? So, okay. So it became less positive till it got to 0, and then what happened after that? Yeah. And both those things mean what? If values become less positive or more negative, it's all decreasing, right? It's all decreasing if values become less positive or more negative. Okay, so R is still decreasing. So what about F? Andrew in the back. So we got R is first becoming less positive and then is becoming more negative.
It's still increasing in the first part, but then once the rate becomes negative, it starts decreasing.
So F, he's saying F is increasing and then decreasing. Agree? Increases, then turns and starts decreasing. Okay. All right, let's go all the way from -1 to 2. Now, ready? So you watch what the rate does. I'm going to go from -1 to 2. Here we go. Okay, I'll do it one more time, and then here we go. Ready? From -1 to 2. Okay, talk to the person next to you. What did you see? All right, I'll do it again. Ready? Okay. Christina.
As R is increasing more negative than
So at first, R decreased or increased?
positive.
Agree with that?
Oh, I know, decreased.
So at first, is it increasing or decreasing? How is it decreasing? More negative, right? More negative. So first it was getting more negative. Then what happened? And then it turned around and started becoming less negative. Is that it?
At some point, it becomes a positive rate.
And then as it was becoming less negative, it reached 0. And after that? What happened after that then?
It became more positive.
More positive. So let's take a look here. When it was becoming more negative, what was the rate doing? This Daniel, red shirt. When the rate was becoming more negative, what was the conclusion? What was it doing? Decreasing. Okay? When it was becoming less negative, what was it doing? Increasing. And what about more positive? So first the rate was decreasing, and then it was increasing. Okay? What about F? So as R was decreasing and R was becoming more negative, what was F? What will F be doing there? Autumn. And why would it be decreasing? What about this information tells us that it's decreasing?
Because the rate is I'm not sure.
Okay? Yeah, Lauren.
Is it because the rate is actually negative?
Because the rate is negative. If the rate is negative, then F is decreasing. Agree? Yeah. So F first decreases. Okay, and then the rate started becoming less negative. What's F doing now? Increasing or decreasing?
Decreasing.
Still decreases. Okay? So first R is becoming more negative, decreasing, but then it's increasing, but it's still negative, so F still decreases. And then when R hits 0 and becomes more positive, then F increases. All right, so the goal is, can we, just based on this information that we had about the rates, decreasing and increasing, what we concluded about the function, now can we make a sketch of this function? Here at the end, at R equals 2. What about F itself? Is it positive or negative? F is positive. Beth, don't know. Josh, what about F? Don't know meaning you're not sure, or there's no way to tell? Stanley, why?
We don't have any information about the actual values of f of x. We know how values are changing, but not what they are.
Right. This whole thing could be up around positive 1,000, going up and down around 1,000, right? Or it could be at negative 500, going up and down the same way, down at negative 500. So there's nothing here that tells us about the actual function values. But knowing the values of the rate and being positive or negative and increasing or decreasing shows us how f is changing. Okay, so can we come up with some kind of shape? So suppose that function is up here around 15. Can we come up with some kind of shape based on this? So we got these three intervals. See if you can work together with the person next to you and come up with a sketch of this graph.
No, increasing is in like, they were going from negative 5
So we'll start here. Around there, yeah.
Stop doing
Got the whole graph? Got the whole graph? Okay, so maybe this will help us to identify. So here's 6 kind of possible shapes of what f could be. So f is increasing, but r is decreasing from negative 5 to negative 3. Yeah. What's A?
Yes.
Right, okay. So f is increasing, that would have to be one of these, right? If for a positive delta x, we get a positive delta y, and that's why, so r is positive. Okay, but the rate is decreasing. And so that would mean our slope is getting less. Okay, how about the next part? So f increases, then decreases. Right to f. He wants f. A little more a, and then f. Okay? So it keeps increasing. But then there's some point. Like this? Yeah, so if f increases then decreases, what do we have to have there at the intermediary point? It's increasing and then it's decreasing. Yeah, we're going to have a maximum, right? We're going to have a maximum. That's the idea of a maximum. If it's increasing and then it changes and starts decreasing, then there's some highest value that it's going to reach. Okay, and we know that max was between -3 and -1. Okay. So at the beginning of this interval, f is decreasing as r is getting more negative. What's that? More f. It's going to be more f for a while?
More F than C.
I say D. A little bit of F and then D.
Okay, so we got some, so it's decreasing and r is becoming more negative. And then what's next?
D.
Decreasing and coming less negative. D?
D. Yeah. And then into some C.
That was bad.
Judge art skills.
What do we think? Okay, so if I graph this, it could look quite a bit different, but, well, now it's moving the axes. Shoot. I'll just verify that you are correct. All right. Okay, so f is increasing, but the rate is decreasing. So how can we see that the rate is decreasing? Yeah, because the slopes are getting less. And it keeps doing that until here. Now, is the rate decreasing or increasing through there? Is the rate increasing or decreasing? This is confusing. Decreasing. This is decreasing because the slopes are getting more negative. Okay, and then rate is doing what here? Now starting here, the rates are getting less negative, therefore increasing rate. Increasing and continue to increase by getting more positive, increasing. Okay. Time to go. Homework for Wednesday. If you want to come get your quiz, I can hand out the quizzes on your way out.